Before the sun has fully cleared the horizon, you're already awake. Not because an alarm went off. Not because you had somewhere to be. You're awake because something moved in the trees about 40 meters away and your nervous system made the decision for you. Cortisol spike, heart rate up, eyes open, before your conscious mind had any input on the matter whatsoever. You're somewhere in the afar region of what will eventually become Ethiopia. It's roughly 3.9 million years ago. You are, in biological terms, an Australopithecus afarensis. You stand somewhere between 3.5 and 4.5 feet tall. Your brain, at roughly 450 cubic centimeters, is about a third the volume of a modern human's. You have hands that can grip with real precision, feet that have recently, in evolutionary terms, committed to walking upright, and a set of social bonds with the 8 to 15 individuals around you that are, right now, the only reason you are still alive. The thing in the trees stops moving. Might have been a bird. Might not have been. Your body doesn't relax immediately, it holds the elevated state for another few minutes, scanning, because the thing that relaxes too quickly is the thing that doesn't see the second movement. And then the day begins. Not with intention. With hunger. That opening scene isn't a dramatization in the Hollywood sense. It's a composite reconstruction built from what the fossil and paleo-environmental record of the Afar Depression and the Litoli region of Tanzania actually tells us about Australopithecus afarensis, the species most people know from the partial skeleton nicknamed Lucy, discovered by Donald Johanson and Tom Gray in 1974. And the reason we're spending this video inside a single representative day at this particular moment in our lineage's history isn't nostalgia or morbid curiosity. It's because understanding what daily life actually looked like 4 million years ago, hour by hour, demand by demand, in the specific physical and ecological context these beings inhabited, changes how you understand every human behavior that came after it. The baseline is weirder than the textbooks suggest. And the distance between that baseline and where you're sitting right now is both larger and smaller than most people intuit. Larger, because almost nothing about the daily experience of an Australopithecus maps onto yours in any direct way. Smaller, because the neurological and social architecture running underneath that experience is recognizable in ways that are occasionally uncomfortable. Let's build the day properly, starting with the single most consuming reality of existence at this moment in our lineage's history, the body's energy budget, and how brutally narrow it was. An Australopithecus afarensis with a body mass of around 28 to 45 kilograms, the range varies significantly by sex, since this species showed dramatic size differences between males and females, burning energy at the rate demanded by bipedal locomotion in a hot, seasonally variable savanna woodland environment, needed somewhere in the range of 1,500 to 2,000 calories per day to maintain basic function. That number sounds manageable until you consider what the caloric landscape of Pliocene East Africa actually looked like. No cultivated crops. No domesticated animals. No food storage of any meaningful kind. The available energy was distributed across a landscape in the form of tubers buried in baked clay, fruit on trees that other animals were also competing for, insects, small vertebrates that were faster than you, plant parts with poor caloric density that required hours of chewing to process, and the occasional scavenging opportunity at a carcass that larger predators had already worked over. Paleoanthropologist Peter Unger at the University of Arkansas has spent years analyzing the dental microwear and isotopic chemistry of Australopithecus teeth. The microscopic scratches and pits on molar surfaces tell you what foods were actually being processed, not just what was theoretically available. What the dental evidence from afarensis populations shows is a diet of significant variety and significant toughness. Hard foods, seeds, nuts, possibly tubers, left distinctive parallel scratches. Gritty foods introduced particles that pitted the enamel. The teeth themselves were large by later hominin standards, with thick enamel suited for processing hard, abrasive food items. This wasn't a delicate, fruit specialist diet. It was a diet shaped by the need to extract energy from whatever was available, including things that required substantial mechanical processing just to be edible. What this means for the shape of the day is that a very large portion of waking hours, estimates from comparative primate data and metabolic modeling suggest something like 6 to 8 hours was spent in direct food acquisition and processing. Walking to find it. Digging for it. Climbing for it. Cracking it, chewing it, dealing with the physical demands of turning raw landscape into usable energy. This is not the romantic, living off the land, picture. It's closer to a full-time physically demanding job where the stakes of underperformance are immediate organ failure, and your employer is the caloric content of whatever you can find before dark. The locomotion dimension of this deserves specific attention, because the transition to bipedalism, which afarensis represents in a critical intermediate form, was not the clean upgrade it gets presented as in introductory anthropology courses. The Litoli footprints, preserved in volcanic ash in Tanzania and dated to 3.66 million years ago, analyzed by Mary Leakey and her team in the late 1970s, show a fully bipedal gait with a human-like heel strike pattern. These beings were walking upright. But the skeletal anatomy tells a more complicated story. The shoulder joints of afarensis were oriented in a way consistent with regular overhead use, climbing. The finger bones were curved in a way that suggests consistent grip on branches. The inner ear canals, which govern balance, showed a configuration intermediate between earlier arboreal hominins and later fully terrestrial species. Lucy's own skeleton, and the more complete Australopithecus afarensis specimens found subsequently at Hadar in Ethiopia, indicate a creature that walked efficiently on the ground but also spent meaningful time in trees, almost certainly sleeping in them, probably feeding in them, and retreating to them when the ground-level threat picture got complicated. Which it got. Regularly. Researcher William Highlander's work on the biomechanics of Australopithecus skulls, and the broader paleontological literature on the Pliocene carnivore community in East Africa, makes clear what was sharing the landscape with these early hominins. Dinofelis, the false saber-tooth that we've discussed in other videos on this channel, left dental evidence at South African cave sites directly associated with hominin remains. Meganterion was present. Giant hyenas. Large crocodilians at every water source. And critically, these predators weren't equally active across the full 24 hours, the peak risk windows were crepuscular and nocturnal, which meant that the transition from day to night, and the management of sleeping arrangements, was one of the most consequential decisions the group made every single day. The sleeping in trees inference matters here in a way that goes beyond simple safety, climbing to a sleeping site at the end of a day that already involves 6 to 8 hours of walking and foraging across several kilometers of varied terrain, on a caloric budget that may not have been fully met, is an additional energy expenditure on top of an already depleted system. The trade-off was non-negotiable: ground sleeping without fire, without weapons capable of deterring a large feline, was probably a reliable way to not wake up. But the cumulative physical toll of that trade-off, day after day, across a lifetime measured in decades at most, registers as a kind of sustained physiological pressure that modern humans in developed countries essentially never experience at any point in their lives. The social dimension of the day is the piece that's hardest to reconstruct with confidence and also, in some ways, the most important. Australopithecus afarensis group sizes are inferred from the fossil record at sites like the Dakika locality in Ethiopia, where multiple individuals of different ages were found in close association, and from comparison with modern non-human primates of similar body size and ecological position. The working model for most paleoanthropologists is groups of roughly 15 to 30 individuals, with a social structure that was probably somewhere between the fission-fusion dynamics of chimpanzees, where the core group splits into smaller foraging parties and reconvenes, and the more stable, bonded group structures of some baboon populations. Within that group, the social intelligence required was already substantial. Tracking who was reliable in a collective defense situation. Managing the reproductive competition that exists in any primate social group. Maintaining the alliances that determined access to resources when food was limited. None of this required language in the modern sense, but all of it required social memory, behavioral flexibility, and the capacity to read and respond to the signals of multiple individuals simultaneously. The cognitive load of group living, in other words, wasn't optional. It was itself a survival task, running continuously alongside the physical work of finding food and avoiding predators. Franz de Waal's decades of research on primate social cognition, primarily with chimpanzees and bonobos, but with implications for reconstructing earlier hominins, consistently showed that the sophistication of social reasoning in our closest living relatives far exceeds what most people attribute to non-human animals. Reconciliation behaviors after conflicts. Coalition politics. The capacity to track third-party relationships, knowing not just your own relationship with individual A, but A's relationship with individual B, and using that knowledge strategically. These capacities didn't appear from nowhere in Homo sapiens. They have deep roots in the primate lineage, and some version of them was almost certainly operating in an Australopithecus group navigating the daily politics of who ate first, who slept where, who responded to whose alarm call. Now here's where this picture needs to be complicated, because the pure survival hell framing in this video's title is doing rhetorical work that the evidence only partially supports. The reconstructed daily life of Australopithecus afarensis is genuinely harsh by any comparative measure. The caloric precarity. The predation pressure. The physical demands of locomotion on a skeleton in the middle of a major biomechanical transition. The absence of any technological buffer between the body and the environment. All of that is real, and all of it registers as brutal against the baseline of contemporary life in any moderately comfortable society. But hell implies a subjective experience of suffering, and that's where the honest scientist has to pump the brakes that we have no direct access to the phenomenology of an Australopithecus, what it felt like, from the inside, to be one. The comparison is always made from our vantage point, measuring their life against standards of comfort and safety that didn't exist as reference points for them. An individual who has never experienced the absence of predation pressure doesn't experience the presence of it as deprivation in the way someone who had known safety and then lost it would. The baseline shapes the experience. And for a being whose entire lineage had never experienced anything other than this particular configuration of challenges, the subjective register of daily life may have been considerably more neutral than our reconstruction suggests. There's also the bonding dimension. The research on endorphin release during social grooming in primates, documented by Robin Dunbar and colleagues, shows that physical social contact generates neurochemical reward states that are, in terms of their subjective quality, genuinely positive experiences. An Australopithecus group huddled in the trees at night, engaged in the social grooming that primates use to maintain bonds, was not in a state of pure suffering. Some version of social warmth, of connection, of the neurochemical signature of belonging, was probably present. The daily life was hard by our measures. It wasn't necessarily experienced as unrelenting misery by theirs. Come back to that morning. The cortisol spike. The scan of the tree lean. The hunger that structures everything that follows. The day that follows that moment, the hours of foraging across several kilometers of savanna woodland, the social negotiation within the group, the management of threat and opportunity in real time, the exhausted climb to a sleeping branch as the light fails and the nocturnal predators become active. That day is the substrate from which everything in this channel's catalog of human behavior eventually grows. Every cognitive bias, every social instinct, every default setting your mind runs on was shaped by selection pressures operating on days like that one, across millions of iterations, over timescales that dwarf recorded history. The hypervigilance that makes your cortisol spike at an ambiguous social situation is the same system that read the tree lean before sunrise. The social anxiety about your standing in your group is the same social intelligence that tracked alliances in a foraging band where your position in the hierarchy had direct caloric consequences. The way your body treats hunger as an emergency even when the nearest food source is a 30-second walk to your refrigerator, that's calibrated to a world where the nearest food source was several hours away and not guaranteed. You are not living in that world. Your nervous system hasn't fully gotten the memo. Understanding where the programming came from doesn't automatically change how it runs. But it does change how you relate to it. And that's worth something. If building that kind of historical psychological bridge, between the specific realities of ancient life and the specific quirks of modern behavior, is what you come here for, then the previous videos in this series are worth your time. We've covered the fears, the predators, the social dynamics. This one is the foundation under all of it. Subscribe, leave a comment with what you think was the single hardest part of Australopithecus' daily life, the predators, the calories, or the social politics, because that debate has a real answer, and we'd like to hear where you land before we make the case. The tree lean is still out there. You just can't see it anymore.